Hello guys, what's up? In this video, we are going to conduct the stress analysis on a shaft that is carrying a gear and a pulley. So in this problem, the shaft carries a gear and a pulley and is supported by bearing at its ends. First, it shows static structural. I'm not going to change the material. So right click on geometry, go to import geometry and choose this geometry. So the download link for the geometry is given in the description. Next, double click on model. Right click on the mesh and choose generate mesh. Now the entire structure it is discretized into small elements. Right click on static structural, choose insert and choose remote displacement. Mhm. So click control and select the two end faces of the shaft. Click apply and in the displacement I'm going to put zero value for the x component to the y component, the z component. Mm-hmm, mm-hmm. Uh, and in the rotation, except the x component, I'm going to put zero for the y component and the z component. Next, right click on static structural, go to insert and choose fixed support. And fix the face of a tooth. Click apply. Next, right click on static structural, go to insert and choose moment. Select the poly face, click apply. So, so moment we can apply in two methods. I'm selecting components and in the X component, I'm applying 25 Newton meter. Oh no, I want it in Newton meter, not in Newton millimeter. So I changed the unit to meter. Okay. Okay, so you can see the direction. Next, right click on the solution and insert, go on with stress, then total deformation. Similarly, in stress tool, you can find maximum equivalent stress. Also, click that, so that will give you the safety factor. Right click on the solution, click solve. Now the solution is completed. You can visualize the result. Click the equivalent stress. So you can see the maximum stress is around 1.768 E bar 8 Pascal. You can also animate it like this. Similarly, you can visualize the total deformation. So the maximum deformation is at the poly side, as you can see. Similarly, you can visualize the safety factor. So the minimum factor of safety is 1.4. So if the factor of safety is greater than 1, then the system is safe. So the dimensions of the given system is completely safe. Woohoo! Thanks for watching. That's it for today's video. Don't forget to like, share, and subscribe for more. See you in the next one.